Hello, my name is Wigersma and I'm here together with my colleagues Reinier Marcus and Henk Peters, and today we're going to show you a functional inspection of a gas control line with our Plexor inspection system for gas pressure regulator stations. In order to demonstrate to you the Plexor system, we have a functional model of a gas control line where we use compressed air to create an inlet pressure of 4 bars with following components: a filter with a differential pressure gauge, a pressure regulator with integrated slam shot device, an outlet section with 100 millibars with a safety relief valve. Here we see the Plexor test device. The system is IEC-EX approved and can therefore be operated inside the gas control station. The main components are a digital manometer for the inlet pressure, one for the outlet pressure. Out here we have a Bluetooth device for wireless connection with a tablet, laptop or PDA. Here we see the function switch, which allows us to operate and test the various devices. This is the test lever to give a standardized pressure rise or pressure fall of 1.5% per second. And here we have the system connections. First one is for the inlet pressure, the outlet pressure, the sensing line of the slam shot device, and finally the ventilation. The Plexor test device uses the inlet pressure to test the components of the gas control line. Various gas control line configurations can be functionally tested independent of the brand of the component.
Part of the Plexor inspection system is the connection software. This connection software contains of several modules: the manager module to manage the data of the pressure regulating stations, gas control lines and boundaries and inspection procedures, the inspector software to perform the visual and functional inspections, and the diagnostics module to analyze the results of the functional inspections.
The Plexor test device will be connected to the gas control line by means of color-coded, double-secured hose connectors. Against the clock, push with the clock, and by the unique dimensions you cannot mix up this connection. Take away the protection cap and connect the hose to the system coupling. All hoses are connected: inlet pressure, outlet pressure, slam shot device and ventilation to the gas control line. All couplings have their own unique dimension, so you are not able to mix up the connection from inlet to outlet. By using the Inspector PC software on the tablet, selecting the gas control line, make connection to the Plexor test device, the operator will be guided step by step through the functional procedure. Before connecting the digital manometers, we press clear 0 to adjust the manometers. Connect to inlet and test pressure and go for the next step. Put the switch into the position control line. And go for the next step. Now, for 30 seconds, the net pressure will be measured, showing us the current value, the boundaries, accuracy range of the regulator, and the last previous value. That's the result of the last test. This measurement is 30 seconds and will log 10 measurements per second. after this beep, the display shows us the complete 30 seconds of this measurement. We are inside the boundaries, so we can continue with the next step. We are now closing the outlet valve and go for the next step. We are now opening the ventilation valve in the gas control line to have a stable situation. Go for the next step. We are now measuring the actual pressure simulated over the ventilation valve to check the set point of the regulator. The value is 100 millibar, accuracy range 95, 105, and the last value was 100.2 millibar. This measurement is also done for 30 seconds. So it's within the rejection boundaries. We are able to continue the measurement by closing the ventilation valve. Next step. Now the locker pressure measurement will be starting for 30 seconds. You will see the current value 106.4, the boundaries 100, maximum 110, and our previous value from the last test was 106.3. So we are inside the limits of the regulator locker pressure. Next step, we are now opening the ventilation valve again and directly slowly closing it again to simulate some pressure. And now for the next step, we measure the second locker pressure also for 30 seconds. The second locker pressure measurement is done to verify the locker pressure set point of the regulator. The next step, automatically starting the leakage for 1 minute by locker pressure. We are now measuring if the valve of the regulator is closed, and we see a leakage value of 0 millibar per minute, and it's within the limits of plus minus 0.5, the accuracy of the Plexor test device. Our last measurement was 0.1 millibar. So you're able to check directly on location the previous value, the today's value, and our limits. The results are inside the boundaries, so we don't have to restart the measurement again. When there are regulators with a slowly closing valve, it can happen that it moves very slowly to closing locker pressure. Then we can restart the measurement again. We go for next step. Now we will start the joystick in position 1, and we are now measuring the inside part of the slump shot device, meaning membrane, O-ring, etc., to test the inside closing. There is no leakage at this moment. So this is completely okay. We can show also the last value. The last value was also 0. So the status is it's fully closed. Now we go for next step. Put the switch into the position slump device plus to measure the maximum set point of the slump shot. We keep the joystick in the start position and wait till the slump device closes. The pressure will automatically increase by 1.5% per second. You see it in the green line. The reaction boundaries are 130, 140, the accuracy range. And now we wait till the pressure meets the set point of the slump shot. The slump shot closes and we stop the measurement. We are now logging the data, and in a few seconds you will see the graph of the pressure increase and the closing of the slump shot. The slump shot closes by 135.6. It's within the boundaries, and our last previous value was 137.3. First measurement is done to measure the sticking value, the second for the actual value, and the third can be done to verify the set point. In this configuration, the safety slump shot has also a minimum protection. So the next step will be put the switch into the position slump shot device minus and go for the next step. For the set point number 1, we keep the joystick in the position start till the slump shot closes. You see the pressure drop of the green line, and we wait till the slump shot closes. At the moment the slump shot closes, we loosen the lever, and now the data is logged and shows us in a few seconds the result of this measurement. The pressure drop value, actual value 8.1, it should be in the limits 0 to 20 millibar, and our last value was 8.2. So the results are okay. We go for the next step and reset the slump shot device for the second measurement. After the second test of the minimum protection, we do not reset the slump shot device and go for the next step. Now we reduce the outlet pressure to 10% under the network pressure. The network pressure is 100 millibar. Okay. And we go for the next step and wait for 2 minutes to stabilize the outlet volume to be able to measure the closing of the slump shot. Now we automatically start for 2 minutes the tightness of the valve of the slump shot device. The slump shot device leakage value is 0.2 millibar per minute. It's inside the boundaries, so it's okay. The slump shot valve is fully closed. After the tightness test of the slump shot valve, we reset the slump shot. Okay. And go for the next step. Now we have tested regulator, slump shot, and now we are changing the hose from the outlet pressure to the safety relief valve. The next step, close the valve in the pipe of the slump shot relief valve. After connecting the hose to the safety relief valve, the next step will be close the valve from the relief valve to isolate the safety relief valve from the gas control line. We go for the next step and put the switch in the test position relief valve. Next step, keep the joystick in position start until the safety relief valve opens. Okay, we can now stop the measurement, and you see we are outside the boundaries. The current value, the set point, the opening value of the safety relief valve is 139.5 and should be within the limits of 130, 135. So there is a message that we are outside of the boundaries, and the operator can decide how to continue or to take action, direct action. We go for the next step. The next step will now measure the closing pressure of the safety relief valve. The closing pressure of the relief valve is 120.3 millibar. The boundaries, the minimum boundary, is 125. So it's outside the boundaries. And after a few seconds, we will see the results displayed on the computer. The measurement is outside the rejection boundaries, and the operator can decide how to continue or take action. We go for the next step. Now automatically the tightness of the safety relief valve will be measured and indicated in a leakage value in millibar per minute. we see that the leakage value is minus 0.2. It's inside the limits, and when this minimum leakage value is minus, then it means it could be having an external leakage. And now you see it's okay, and we don't have to restart the measurement, so we can go for the next step. After this test, we are able now to enter some observations, and in our opinion the test was okay. Test is okay. We release all hoses from the gas control line. Inlet pressure, outlet pressure, safety relief valve. And we go for the next step. Put the switch into the position Plexor minus. Keep the joystick in position start. Now we are ventilating all pressures inside the Plexor test unit and the hoses to be able to make a new measurement on another gas control line. Both manometers are showing us that there is no pressure anymore in the Plexor test device and the hoses. So now we can go to the next step. We put the gas control line back in the working position. Opening the outlet valve. And go for the next step. Is the gas control line in the original working position again? Yes. Next step. Is the control center informed that we have finalized the test? Go for the next step. And now we can enter the name of the operator and go for the next step. The operator's name will automatically stored in the protocol. Next step. We are now at the end of the test procedure, and we can prepare for our next functional test on another gas control line. And at this moment we are able to restart the program by testing those measurements which were outside the limits. When we do now start the re-inspection, those measurements will be or can be done again.
During the functional test with the Plexor test device, two datasets are generated. One dataset contains the results that can be presented in a protocol, and it contains all the measured values, as you can see here. The second dataset contains all the measurements of the complete functional test. By this dataset, I'm able to present the complete functional test in one graph, as you can see here. I can present up to 10 measurements in one graph, so I'm able to see if there are any trends visible on components, how they perform. The graph also shows the boundaries, so I can see if the measurements were inside my boundaries, yes or no. If I see trends, I can decide on to change my strategy, to stretch my maintenance and inspection intervals. And by doing this, I can save a lot on labor and spare parts. Concluding that by using this system, a lot of money can be saved.